parts of the body to change their action, all in the name of homeostasis. The whole thing we're trying to do here with our endocrine system is maintain homeostasis, bring our body back to normal function. And in doing so, the hormones that are released by the endocrine system are going to help with everything from reproduction to growth and development, mobilizing body defenses, maintaining homeostasis through the increased or decreased function of some organ or gland in the body, and then the regulation of metabolism, which in this particular case, metabolism doesn't mean if you're skinny or if you're heavyset. What this means is metabolism is a cell doing its normal function. So the endocrine system helps cells to do their normal function, again, all in the name of homeostasis. If you remember back to chapter 1, we talked about 2 organ systems that played a very important role in maintaining homeostasis. One was the nervous system, and the other was the endocrine system. And I said that the nervous system allowed for very quick changes to the body's normal function, but didn't last very long. The endocrine system makes long-term changes to the body, but it takes a while for those changes to take place. So we're going to talk about the keys to take away from this chapter are all the different organs and glands that are part of the endocrine system, all the hormones that those organs and glands release, what those hormones do, and then we're going to talk about a series of diseases that occur when those organs or glands don't secrete their hormones properly. So you need to know all those diseases as well. So the hormones for each of these organs and glands are going to be produced by specialized cells of that organ and gland. And these hormones will be secreted into the extracellular fluid, or the interstitial fluid. From there, that interstitial fluid, the hormones in the interstitial fluid rather, will be absorbed by our bloodstream, and the bloodstream is what ultimately carries all those hormones to different parts of the body, which is how a hormone released from your pituitary gland up here in your brain can actually travel all the way down and tell your uterus to do something, right? A huge travel when you think about the size of your body. Once these hormones get to the body, these hormones will regulate the activity of the cells of whatever target organ they have. So if your pituitary gland secretes a hormone like oxytocin, which regulates how the muscle of the uterus contracts, that hormone will jump into the bloodstream, travel down all the way to the uterus. Once at the uterus, it will connect with receptors on the muscle of the uterus, and ultimately that hormone will tell the uterus to contract and put women into labor, for example. When we think about hormones are ultimately classified in one of a couple ways. Either amino acid based, steroid based, which means they're made of fat, or prostaglandins. And each of these 3 different types of hormones, they all act in the same way in that they all tell cells of the body what to do. The difference is how they do it. When we think about hormones that are fat soluble, right? So fat soluble hormones. These hormones, when they travel to the cell, because they're made of steroids, which is a variety of fat, these hormones will simply diffuse into the cell. Once into the cell, they'll enter into the nucleus via one of the nuclear pores. And once into the nucleus via the nuclear pore, they will ultimately tell the cell what to do from the nucleus. They will actually cause the nucleus and the chromosomes, DNA of the nucleus, to produce proteins via protein synthesis. And that protein synthesis will make this cell function in a very specific way. As opposed to non-fat soluble hormones, non-fat soluble hormones can't get themselves into the cell as easily, so instead they attach to receptors on the plasma membrane, these proteins that we find on the membrane. And once this hormone and this receptor meet like a lock and a key, that creates a change inside the cell, which allows this cell, again, to do something different, so that, again, this cell and the tissue that it belongs to will change its function so that we can ultimately maintain homeostasis. And when we think about how hormones are ultimately going to affect the cells of the body, there's three categories of hormone stimuli. One is hormonal, humoral, and neural. In a hormonal stimuli, which is the most common, is when an endocrine organ is activated by other hormones. So for example, if here's our pituitary gland, and it secretes a hormone, and let's say this is called TSH, which stands for thyroid stimulating hormone. And what do you think thyroid stimulating hormone does? It stimulates the thyroid, hence the damn name of the hormone. So here's our thyroid, and where's our thyroid found? In your neck. It's right here. All right, the thyroid's right here. So when this hormone comes to the thyroid, it causes the thyroid to secrete its hormones. Because a hormone stimulated this gland to secrete its hormones, that's known as hormonal stimuli. If a hormone tells a gland to secrete its hormones, it's a hormonal stimulation. And so here's the example. I mean, the book used, this is a good example of what I was trying to show on the board. Pituitary gland secreting thyroid stimulating hormone, which tells this hormone to secrete its hormone. That's hormonal stimulation. Humoral stimuli is when a change in our blood chemistry causes the release of a hormone. They used calcium, okay. So, think about it this way. What hormone gets released after you eat food? Insulin, right? And what does insulin do?
Takes up glucose?
It tells glucose to go from our blood into our cells. So you eat food, you eat breakfast, lunch, dinner, snack, whatever it might be. Your blood chemistry changes, right? Now our blood increases in glucose. That increase in blood glucose, increase or changing blood levels, that causes you to release a hormone. We call that humoral stimuli. The example your book uses is calcium, which we haven't gotten to yet. I don't expect you to know about the parathyroid gland yet, but another variety of humoral stimuli occurs when you ingest calcium and our blood levels of calcium rise. When blood levels of calcium rises, we secrete hormones that specifically they'll get released because of changing in calcium levels, and that will lead to the release of the parathyroid hormones. So again, if the change in our blood chemistry is what causes hormones to be released, we refer to this as humoral stimuli. And then last but not least is neural stimuli. Neural stimuli is simply when the nervous system stimulates the release of a hormone. So if the brain specifically tells a gland to secrete its hormone. And there's a couple examples of this. The example your book is using is showing how the nervous system can tell the adrenal medulla, which is what this gland is here, to secrete its hormones, specifically epinephrine and norepinephrine, which is known as adrenaline or noradrenaline, and this is what ultimately causes us to go into fight or flight or maintain fight or flight, which is the autonomic nervous system. Another good example of this is the posterior pituitary, which secretes two very important hormones. One of them is oxytocin, the other one is antidiuretic hormone. Those hormones are told to be released specifically by the brain, the hypothalamus, which controls the pituitary gland, if you remember back to the nervous system. The hypothalamus literally tells the posterior pituitary to secrete its hormones. So if the brain tells the body to secrete its hormones, we refer to this as neural stimulus. And so when we think about the endocrine system itself, the endocrine system is made up of a series of organs and glands, all shown here. The hypothalamus, which yes is part of the nervous system, but it also is a part of the endocrine system because the hypothalamus controls the pituitary gland. The pituitary gland is going to be the one we really talk about the most today. It secretes 9 very, very distinct hormones that have 9 very, very distinct functions. The pineal gland, which we've already talked about, the pineal gland secretes what? Melatonin. Melatonin is a type of hormone which helps us with our sleep-wake cycle. Thyroid, the parathyroid, our thymus, which we're not going to talk a ton about until we get to the lymphatic and immune system, because it plays a bigger role there. Adrenal glands, our pancreas, and the gonads, which gonads are the testes for men and ovaries for the ladies. So what we're going to have to do in the crux of this chapter, what I'm really wanting you to get away from this chapter, is can you name all of these organs and glands? Can you tell me all of the hormones that each of these organs and glands releases? And can you tell me what those hormones do? So if the parathyroid gland secretes parathyroid hormone, what does that do to your body? And then last but not least, there's going to be a handful of diseases we're going to talk about. We're going to talk about dwarfism, we're going to talk about gigantism, we're going to talk about diabetes mellitus and diabetes insipidus, all kinds of diseases. What are those diseases and what causes those diseases to occur? If you can give me all that stuff, you'll do very, very well on this part of your next exam. So let's start with the pituitary gland. The pituitary gland is ultimately that little small grape-like gland that we saw hanging out in what part of the sphenoid bone? You're going to want to know. You might want to know that one first.
Is it the
Sella turcica. It's in the sella turcica of the sphenoid bone, right? That little saddle that we saw in the center of that sphenoid bone, that's the sella turcica. And inside that sella turcica, that sella turcica houses and protects our pituitary gland. It's only about the size of a pea. It hangs from the brain, specifically controlled by the hypothalamus. And it's separated into 2 parts, the anterior and posterior pituitary. The anterior pituitary is purely glandular in that the anterior pituitary gland is completely separate from the brain. Meanwhile, our posterior pituitary, which we see here, is actually an extension of the brain. The hypothalamus actually has neurons that travel down and make up the majority of our posterior pituitary. Therefore, the posterior pituitary is directly controlled by the brain, specifically the hypothalamus. The hypothalamus controls the anterior pituitary, but it does so by secreting hormones. And each of these parts of the brain, each part of the pituitary secretes very specific hormones. The posterior pituitary, which we'll do first, secretes 2 very important hormones. The first one is called oxytocin, and the second one is antidiuretic hormone, which is abbreviated ADH. And my recommendation is that you memorize both the name and its abbreviation. Because if you think I'm going to ask you what does thyroid stimulating hormone do, as opposed to what does TSH do, you're crazy. I'm not going to tell you the name of the hormone if the hormone gives away what it does, right? So know both names. So first one that we'll talk about is oxytocin. Oxytocin's job is real simple. It puts women into labor. When mom gets pregnant, right, and as baby grows, the pressure within mom's uterus increases. What structure separates the uterus from the vaginal canal?
The cervix.
The cervix. The cervix is what separates the vaginal canal from the uterus. As baby gets to full-term weight, baby's head is pushing down on the cervix. And the cervix is nothing more than a ring of muscle. Think of it as a donut, right? It's got a hole in the center and muscle on the perimeter. And as baby's head pushes against the cervix, what happens to the cervix? It starts to dilate, which is just a fancy way of saying what? You're right. It starts to open up. The hole opens up. It stretches. Is that homeostasis? is it normal for a woman's cervix to stretch? No. So the endocrine system is all about trying to maintain homeostasis. So what's it going to try to do to that lady's cervix?
Make it smaller?
It's going to try to get it back to its normal size, right? That's its goal. How does it do it?
Contraction?
Contracting of what?
Uterine muscle?
The uterine muscle. Because if the uterine muscle contracts, what happens to the baby?
Comes out.
It's ultimately going to be born, correct? And once that baby's born, is there anything pushing against mama's cervix? No. So what's going to happen to the cervix size?
Sure.
It'll go back to normal, will it not? This hormone, when secreted, will tell the muscles of the uterine wall to contract. And as such, mom goes into labor. It will cause the cervix at first to stretch even more, will it not? Which is why mom gets dilated, right? And they're constantly checking while mom's in labor, 2 millimeters, 3 centimeters, 4 centimeters. And once you get to how many centimeters do they tell mom to push? 10. Once you get to 10 centimeters, which is about 3 fingers, that's when they tell mom just to push. And then the baby gets born, and once the baby is born, cervix goes back to homeostasis, right? Oxytocin's done its job. On top of that, after mom bears the child, this hormone will cause mom's breast tissue to release milk. How many moms in the house? Just the one? What's the first thing they asked you to do after your baby was born? You had your kids at the hospital, right?
Mm-hmm.
Okay, good. So after, because like if you had them in a bathtub, I don't know what those folks do. That's just crazy shit. So it is. There's hospitals. They have meds and doctors and nurses and all kinds of good people. All they do for their living is birth babies. Why would you have your kid in the bathtub? So, what's the first thing the nurses, after they weighed him and cleaned him up or her up to make him look not so much like a wet lizard, they gave him back to you. What's the first thing they asked you to do? In the waiting, you literally just had the baby like 2 minutes ago. What's the first thing they asked you to do?
He was premature, so he went right to the, he was premature, so.
Oh, yeah, all right, so
Yeah.
you're a special case. All right, I can tell you from my 4 experiences with watching my wife give birth to our children, the first thing they did after they clean him up and they weigh him and they check his heart and all that, is they give him back to mom and they said, hey, try to breastfeed. Why do they ask mom to breastfeed right there? I mean, she literally just spent like the last half hour pushing this 10-pound butterball out of her body, right? We had big kids. No, our biggest was 10, our smallest was 9'3". We had big kids. So why did they ask mom to breastfeed right at that moment?
She has oxytocin.
She's up to her ass in oxytocin, right? Her oxytocin levels are sky freaking high. So at that point in time, if oxytocin also causes milk to be ejected, let's use it. Let's use the oxytocin that's already in her bloodstream to breastfeed. It has nothing to do with the mom trying to bond with baby. You have 18 years to bond with that little heathen, right? You are going to bond like a son of a gun with that kid over the next 18 years, all right? That 5-minute window, like you didn't get to bond with your child. Have you bonded with them since?
Mm-hmm.
Yeah, all right? If anything, you're like, I need a little less bonding. Go somewhere else, right? So at the end of the day, there's 2 key ingredients, there's 2 key functions that oxytocin does. The first thing it does is it causes contraction of the uterus, puts mom into labor so that we can ultimately, and that occurs because of the stretching of the uterus, the cervix as the baby is descending. The second thing it does is it causes milk to be ejected from the breast tissue, mammary glands in particular, when baby wants to feed. It doesn't cause the production of milk, it just causes milk to be released. Everybody cool with oxytocin? When you go to the hospital, what's the one thing they inject pregnant moms with? The synthetic version of this. Anybody know? It's called Pitocin. So when you get to the hospital, if they say we're going to inject you with Pitocin, what they're basically doing is they're injecting you with a synthetic version of oxytocin, which will help to promote contractions of the uterus and just put you further into labor.
Is that the same as like an epidural?
No. Epidural, that's a saddle block, baby. That's going to make you not feel anything from here down.
Yeah.
Yeah, that's a completely different animal. That's a pain management doctor. Love those people too. That's another thing. We have really good drugs. Why would you feel that if you don't have to?
Right?
Son of a gun. Numb it up. Let's just go to town. All right. The other hormone from the posterior pituitary is antidiuretic hormone. What do you think this does? It's an antidiuretic. What's a diuretic do?
When I think of that, I think of dialysis.
Well, you're in the right neighborhood,
So kidneys.
right? So what do our kidneys do? Why do we have kidneys?
To use bathroom.
Huh?
Help us use restroom.
In particular, what do they make us do? Do they make us pee or poo? One or two?
Pee.
They make us pee, right? Kidneys produce urine. So the kidneys cause us to urinate by making urine, which is liquid waste, right? It's pretty simple. If a diuretic makes us pee more, what does an antidiuretic do?
Make it stop.
Makes us pee less. This hormone prevents us from producing urine. But more specifically than that, it prevents us from releasing water. And why in God's name would we want to not pee? There's a couple examples of why. But what could be possibly happening in the body that would tell us, hey, you know what? Let's not pee at all. Let's just pee a lot less, keep all that water and material in the body. There's two good scenarios.
What, surgery?
Nah,
Fight or flight scenarios.
you hit me with a good scenario there. Don't get me wrong, if you're fight or flight, you're certainly not going to be peeing at that moment in time, but that's not the endocrine system at work, that's the nervous system at work. But at least you're thinking in the right frame of mind, but that's a nervous system reaction, not an endocrine reaction.
Increased blood pressure?
If you have too much blood pressure,
No, if you have low.
now we're talking. Blood pressure. If your blood pressure is low, right, what's one easy way to raise your blood pressure but to add water to your bloodstream, which makes your blood volume greater, which will increase your blood pressure. So one definite way is to increase our blood pressure. What's another one that's a lot easier to think about? It happens to a lot of people in the Houston summers.
Or dehydration.
We get dehydrated, right? If you're already dehydrated because you've been sweating out water, our body's gonna conserve water because we wanna have water in our system. We need to be well hydrated. So the one thing that'll happen is we'll stop urinating. This hormone will travel to the kidneys and tell the kidneys to stop allowing water to leave the body. So as a result, the water that we are putting into our urine will get brought back into our bloodstream. It'll increase our blood volume, which increases blood pressure. It'll ultimately help us to fight off any dehydration we have. This hormone will also tell our skin to stop sweating. The one thing in Houston, if you're sweating, at least you know you have water in your body. If you stop sweating in the Houston sun, you're in deep, deep trouble. You better get some water in you soon. That's a sign that you're running out of water. And that can be bad for your heart. It can ultimately be bad for your health. Everybody coached with antidiuretic hormone. Now there is a disease of antidiuretic hormone. This disease is called diabetes insipidus. This is when your body does not have ADH. It doesn't secrete enough antidiuretic hormone. So diabetes insipidus is a disease of the posterior pituitary when the posterior pituitary does not secrete enough or does not have the ability to produce antidiuretic hormone. What do you think the symptoms of this disease are going to be?
Pee a lot?
You're going to be peeing all the time. So you will urinate much, much more often. As a result of that, if you pee all the time, what are you going to be as a result?
Dehydrated?
Well, it can lead to dehydration. So this can lead to dehydration.
Oh, thirsty.
You're going to always be thirsty, right? So these people have increase in thirst. What other disease has a calling card of people who pee all the time and are constantly thirsty, which also has this word in it.
Diabetes mellitus.
Diabetes mellitus, right? Diabetes, people with diabetes mellitus, which is a problem controlling what?
Glucose.
Blood sugar, right? If you can't control blood sugar, you have diabetes mellitus. People with diabetes mellitus are always thirsty, they're always hungry, and they're always peeing. As a result, the reason why this is called diabetes insipidus is because it has 2 of the 3 calling card symptoms of diabetes mellitus. Yet this has nothing to do with blood sugar. This all has to do with a lack of antidiuretic hormone.
I was just gonna ask, is this more common in elderly people? Or
No.
it could be anybody?
No, this isn't more common. I mean, old people pee a lot, don't they? But that's because everything else is breaking down a little bit, yeah. Old bladders are old bladders, they don't stretch as well as they used to, right? This is gonna be more common in people with pituitary tumors or post-brain surgeries or brain traumas, stuff like that. This is not a hugely common disease, but it's a cool disease nonetheless. Everybody kosher with diabetes insipidus? Good. So let's move on to the anterior pituitary. Our anterior pituitary secretes a few very important hormones. All of these have abbreviations. So, this is human growth hormone. So we go with prolactin. Here's the next one, follicle stimulating hormone. So these are the key hormones secreted by the anterior pituitary. There's actually one more called melanocyte stimulating hormone, but your book doesn't include it, so we'll leave it out. Melanocyte stimulating hormone ultimately controls how melanin is produced by your skin, therefore increasing skin color in the presence of the sun. So we're going to take a look at each of these one at a time, because each of these plays a very, very important role in how the body functions. All right? On the test, I traditionally use the abbreviations. Because again, thyroid stimulating hormone, it's not easy, it's not that hard to figure out what that does for a living. But if you don't know that TSH stands for then you're screwed. So at the end of the day, I will use a lot of abbreviations, so make sure you know them. All right, so let's talk about human growth hormone first. Human growth hormone, or HGH, the job of this hormone is to allow for the muscles and the bones to grow. Skeletal muscle and long bones. This is what makes our long bones longer and what makes our skeletal muscles grow bigger. This is the hormone that's used specifically in puberty. My son Jack is about to turn 18. A year and a half ago was 5'9" on a good day. He's 6'4" right now. Right, so in a year and a half, he went from 5'9" to 6'4". The difference between Jack a year ago, or a year and a half ago, and today is being caused by how much human growth hormone's been produced by his anterior pituitary, which has gone down to his long bones and told them to get longer. Right? Thankfully, I think he's done growing. And as a result, his muscles have responded as well. Ultimately, this is the hormone that's going to play a huge role in determining your final size, specifically height. So however tall or you are or aren't, is because of the amount of human growth hormone that was secreted throughout your young life. And there's 3 diseases that occur because of human growth hormone. Can anybody name one of them? Man, you picked the oddball of the 3, but it counts. Disease number 1 is acromegaly. Acromegaly is caused by an increase in human growth hormone above and beyond normal after puberty. People with acromegaly tend not to be necessarily gigantic people. They don't have to be 7'7" and 550 pounds. Because if right now my anterior pituitary decided to secrete more human growth hormone, would I get taller? No. Why? Because my bones are done. My epiphyseal plates are done. There's no cartilage left in my long bones to make them longer. I can't get taller. If anything, all I can get is shorter, right? So people with acromegaly, due to an increase in human growth hormone after puberty, they're not necessarily, they can be big people, right? They can be 7 foot tall. Where you're really going to see this is in their hands and feet. And their face. And that's where the growth is going to come. These are people who are going to have very pronounced foreheads, longer chins, big cheekbones. Their eyes will look sunken in. When you look at their hands will be big and thick. Anybody know who the Great Khali is? The Great Khali is a good example of what someone with acromegaly looks like. Look up, next time you're on the computer, half of you are on them now, and not paying attention. So look up the Great Khali, right? And see what it says. Now you'll see a good picture of what an acromegaly face looks like. Now, if human growth hormone after puberty is called acromegaly, the increase in human growth hormone after puberty is acromegaly. What is the increase in human growth hormone before puberty called? That's gigantism. So if you release it before puberty, it's referred to as gigantism. And these people are truly going to be gigantic. These are going to be people who are 7 foot tall, 400 or 500 pounds. What's the quintessential example of gigantism in American pop culture? You should have all heard of him.
Yao Ming? Or
Yeah, no, Yao Ming's just one tall, that's just one tall Asian dude, man. I don't know how that happened, but that's awesome. I love me some Yao Ming, but no, he doesn't have gigantism.
Oh.
Anybody heard of Andre the Giant? His condition's in his name. Andre the Giant, he was a pro wrestler. He was popular in the 80s. He was in a movie called The Princess Bride, which if you haven't seen, it's a must-see movie. It's a great movie. Andre the Giant had gigantism. And Andre the Giant was probably 7'6", 550 pounds. He was just a gigantic human being. He had gigantism. Right? So if you want to see what gigantism looks like, go on the internet and look up Andre the Giant. He had hands like shovels. Right? He was just this big dude, right? He had gigantism. What is the absence of human growth hormone called? Dwarfism. Doesn't matter if it's before or after puberty. It's going to be before puberty, but these people do not produce enough human growth hormone. And as a result of their lack of human growth hormone, they lack in size. Now, dwarfism, or people who are of short stature, right? And what for someone to be considered a little person, because a dwarf is not the kind term, a little person, what is the height requirement that they have to be under?
48?
I think it's 4'10". I'm pretty sure it's 410. Anything under 410, I think you're considered a little person. Right? So these folks, this is one of the causes. Right? There's other causes of dwarfism, but the most common variety are people who just lack human growth hormone. Everybody kosher with human growth hormone? Prolactin. What does lactin mean? What's lactation? Milk. And if you're pro-lactation, what are you? You're pro-milk, right? This is a hormone that produces milk. It's for milk. So prolactin causes women, upon being pregnant, to begin producing milk. What's the one thing that happens to women's breast tissue when they're pregnant?
Swell.
They swell. Why do they swell? Right, it's not because you add fat to your breast tissue. It's because those breast tissues, those mammary glands in particular, are producing milk. They're storing milk so that when baby is born, mama has the ability to feed the child. So after mom gets pregnant, she will start to produce milk. The hormone that gets released that tells the mammary glands to produce milk is called prolactin, or PRL. It's a PRL. This is wrong. PRL. Everybody kosher with prolactin. Doesn't really have that big of a function in men since we don't produce milk. One would hope. Gonadotropic hormones. All right? There's two hormones from the anterior pituitary that specifically stimulate either the testes or the ovaries. The first one is called follicle stimulating hormone. Follicle stimulating hormone tells the cells of the testes or the cells of the ovaries to produce their specific sex cell. So in the ovaries, this hormone will cause the ovaries to produce the egg that's ultimately going to be ovulated. In men, when this hormone gets released, it tells the testes to produce sperm. So if our sperm count drops a little bit, this hormone will get released, testes produce more sperm, this hormone shuts off. Ladies, at the beginning of your feminine cycle, during those 5 days of menstruation, this hormone gets released in great amounts so that you can begin developing next month's egg that you're going to ovulate. Luteinizing hormone, on the other hand, or LH, luteinizing hormone tells women to ovulate. Women, you're on a 28-day cycle while you're in your birthing years. What day of that 28 cycle do you ovulate your egg?
Something like it.
Day 14. Day 14. Day 14 of that 28-day cycle is when you ovulate your egg. And you ovulate the egg because luteinizing hormone skyrockets, and it tells the ovary, secrete the egg. The egg gets released and gets put into the fallopian tubes and starts traveling toward the uterus. If you're trying to get pregnant that month, hopefully sperm are coming the other way at the same time, and they meet in the middle, and fertilization takes place. If not, that egg will travel to the uterus and be flushed out with the menses from next month. For men, this tells men to produce testosterone. Ladies, once you get past 18, your ovaries really don't produce the majority of your estrogen. The majority of your estrogen really gets produced by your adrenal glands when it comes to sex drive and things like that. But for men, our main source of testosterone throughout our lives, from very, very young to very, very old, comes from our testes, so this hormone plays a big role in that. The last two. The book calls it thyrotropic hormone. Really what it is thyroid stimulating hormone. I'll never call it this. Ever, 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 ever will I call it this. I will always call it TSH. Thyroid stimulating hormone, as the name implies, tells the thyroid to secrete its hormones. And the thyroid secretes a couple very important hormones. right, hormone number 1 and 2 are T3 and T4. T3 and T4, which are secreted by the thyroid gland, increase cell metabolism. They travel to other cells of the body, and once interacting with those cells, those other cells will increase their cellular function. With regards to T3 and T4, if there's too much T3 or T4, we refer to this as Graves' disease. And Graves' disease is a disease where people have way too much thyroid stimulating hormone or way too much T3, T4 for whatever the reason. And as a result, these people end up getting something called a goiter. And what's goiter? Anybody know what a goiter is? It's when you have like a big ball of tissue right here. It looks like you have like a tennis ball underneath the skin in the front of your throat. Right? And that happens when we have increases in T3 and T4. The thyroid gets bigger. It's a nodule. This also causes people to have increased cellular function, which sounds good, but it's actually a bad thing. This will kill you. If you don't treat it, this is going to cause your heart to go way too fast. Well, if your heart goes way too fast for way too long, what does it do? It stops. If your engine runs way too hard, way too fast in your car, it'll eventually break down, right? Right? So same thing with your body. We want to have increased function at times, but we can't have it all the time, right? You have to be able to cool off all these organs too, which can lead to this can lead to death. No good. Decreases in T3 and T4. There's a few of them, but the one that I really want you to know is something called Hashimoto's disease. Hashimoto's disease is ultimately autoimmune. And what does autoimmune mean?
Your body attacks itself.
Correct. Your immune system is attacking its own body. So if my immune system is attacking my thyroid and destroying the cells that produce T3 and T4, am I going to produce as much T3 and T4 as I need to? No, I won't produce as much because those cells are being destroyed. As a result, there'll be a decrease in T3 and T4, which causes all of this to go down. And as a result, these are people who tend to be, these are going to be very lethargic people. These people are going to have a hard time controlling weight. So you're definitely going to see an increase in their weight. Equally as tough a disease. We treat this one by oftentimes cutting out the thyroid or putting them on medication that blocks the ability of the thyroid being stimulated. This one's typically treated by giving them the hormones that they're not able to produce. We just give synthetic versions of the hormones and try to control it that way. Because we really don't understand how to control autoimmune diseases. There's a whole host of them. Last one is our adrenocorticotropic hormone, otherwise known as ACTH. And ACTH, when released by the anterior pituitary, will ultimately cause the stimulation of our adrenal glands. It'll stimulate our adrenal glands to secrete its hormones. And we'll get to those hormones the Tuesday we get back from spring break. All right, we've already talked about the pineal gland, so. All right, so we have a lab exam coming up in a little bit. I can tell you right now, I've got to make some significant changes to your lab exam. Whoever made the test really likes the eye and the ear. And we can get to the eye and the ear, so I gotta change all those questions.